Now looking at the public cloud, there are different vendors are there. You can see that we have AWS, we have Google Cloud Platform, and we have Azure. These are the three market players, top market players. And right now we have picked up the AWS as a cloud scaling. So you can also jump to Google Cloud, or you can jump to Azure once we get expertise into the particular cloud vendor. Now, if you look at this cloud space, the overall cloud space is going to be targeted as a public cloud. This is your public cloud. Okay. Now, assuming that this is AWS, and AWS is offering a public cloud environment. So what do we mean by that public cloud? Public cloud is something where any user or any business entity can connect with this AWS cloud via the public internet. The highlight here is the public internet. Okay. For example, you might be having a Wi-Fi in your home and you're connected to the internet, right? That's what we call it as a public internet. But we also have a private network or a private internet, and that's something different. But right now I'm talking about any communication that you do on the cloud via the public internet will be categorized as a public cloud. We go to the cloud and we get the service that has been offered by the cloud. So each and every cloud vendor will have the similar setup, but they might have their own functionalities. The cost might vary, their services might vary, their reliability might vary. Okay, their resilient might vary, or their disaster recovery, we call it as DR, disaster recovery might vary. Okay, but ultimately they are all under the cloud environment. Okay, they all fall under the cloud principle. So these vendors will have a specific cloud principle which need to be met with, and if it is met, they are considered to be a cloud vendor. So now, having said that this is a public cloud environment, now we will have the multiple customers who will keep connecting with these cloud environments. You can see that here. I have a customer A, customer B, and customer C who is connected with these public cloud, and how they are connected with the public cloud via the public internet. Okay. So let's say, for example, for computing purpose, they are connected with this cloud, and they make use of the compute services that's been offered by AWS or Google Cloud or Azure. Okay. But those services can be accessed only through this public internet. We go and connect with the AWS infrastructure, and then we consume the service. That's what we call it as public. So any customer, any business unit, any individual can connect. So let's say, for example, you have created an account last week and you are connected with the AWS. That's a practical example of public cloud. Okay. We have created an account and we are connected to this infrastructure of AWS, means it's a public cloud, right? Now, if you look at the definition here, the public cloud providers offer services via public internet. That's what I'm stressing out again and again. The moment we talk about the public cloud, it means that it's accessible for the public, but technically to say the public who's on the public internet can communicate with the public cloud. So you or me who created an account recently and accessing the AWS infrastructure is a quite good example that we can take for public cloud environment. Okay. Hope this makes sense for you people. I will come back to your queries at the end. Okay. Right now I'm not going to take up any of the query. We'll move on with the next cloud, and that's called as a private cloud. When we are on the private cloud, how it's going to be designated with all the accessibility. You will see the diagram here. So let's understand the definition first. On-premise private cloud solution, it is called as on-premise private cloud. The notable point here is your cloud provider, the AWS, will come and host the entire AWS set of infrastructure in your premise. So let's say, for example, it's an offshore location. Okay. So I go to the X company, me as an AWS, I go to the X company and I will provision the entire AWS infrastructure into that particular premise. And that is called as on-premise cloud. The on-premise cloud is actually called as a private cloud. You're getting it? on-premise deployment of the whole AWS infrastructure will be considered as a private cloud. So if you look at the definition here, while privately hosted clouds are located at an offshore location, so you or me not under the private cloud. If we own an organization, and if the AWS team comes to our organization and deploys the AWS setup in our organization, then that setup is what we call it as on-premise private cloud. So if you look at this diagram, this stays the same. Okay, whether it's a AWS or Google Cloud or Azure, it's all the same. Okay, but the term here is it's a private cloud. It's not a public cloud. Earlier it was public cloud. Now the term have been changed to private cloud. How it will vary? Let's see an example. So we have an enterprise like Ford or BMW or Audi. Okay, and they have their data centers. You can see it's an on-premise diagram, and next to the on-premise, what you can see as a picturization there is nothing but the data centers. They have their own data centers. Ford is having a data center, BMW is having their data center, and Audi is having their own data center. And they might be geographically diversified, and they might be located in different geographical location, doesn't matter. But still, they want the AWS infrastructure to get deployed exactly into their data center. So AWS, now the diagram flow will change. If you look at here, AWS team comes to Ford premise and then deploy the AWS infrastructure into that particular data center. So they have their own dedicated cloud environment for their premise or for their data center. You're getting it? The same way how it is achieved. AWS call that setup as a AWS outpost. Okay. Technically, there is a concept called AWS outpost. They come out of the AWS environment and provision the complete AWS infrastructure. Not the complete, probably based on the requirement of the customer, they will provision the setup, and that's called as AWS outpost. The same way Google does. Google also has the support for private cloud, and they provision it with the help of, I'm sorry, it has been interchanged. The diagram have got interchanged. If you look at it, the Google Cloud will perform it with the help of Anthos, and Azure will do it with the help of Azure Stack. You're getting it? So all three terms coins for the same private cloud deployment on-premise. You're getting it? So Google Cloud achieves the same with Anthos, Azure achieves with Azure Stack, and AWS achieves it with AWS Outpost. So this setup is what we call it as your private cloud. Now you can see all three have their dedicated channel of cloud deployment or cloud infrastructure in them. So it's been isolated. You can also see that the picture clearly depicts that they are isolated from each other. They have their own zone where they have created a cloud environment in them, and they are utilizing all the AWS features within their data center itself. They are not going to the public. They need not go to the public internet to connect to the AWS. They are completely isolated. They are completely secured. They have their own custom environment of cloud setup, which has been achieved with the help of the cloud vendor like AWS or Google Cloud or Azure. So this setup is what we call it as on-premise dedicated private cloud. The term is very important, dedicated, right? AWS comes to X company and it dedicatedly deploys the entire cloud structure or cloud infra. So now this is all about the private cloud. Now coming to the hybrid cloud, we saw the public cloud, we saw the private cloud, and now it's all about the hybrid cloud. Now looking at the hybrid cloud, a cloud computing environment that uses a mix of on-premises. Okay, it is a mix-up of your on-premise and your public cloud. You're getting it? Like for example, Ford. Okay, Ford will have a certain environment to be on-premise, and certain environment will be dependent on the public cloud itself. So private cloud and the third-party public cloud services will be clubbed together in an orchestration fashion. Okay, their integration will be orchestrated between the two platforms of the public and the private, and that's what we call it as a hybrid cloud. So if you look at this, the same diagram which I have come up with, so AWS Outpost will be there, and Anthos will be there on the Google, and Azure stack will be there. It should be there. Okay, this is very important. These setups should be there in the hybrid. Partial setup will be done in the Ford, and partially Ford will depend on AWS. So it's a combination of both. You can see it's clubbed now. Your Ford on-premise cloud setup will in turn also communicate with the public cloud. Okay, and the BMW will communicate with the Google Cloud Platform by having the BMW's own cloud infrastructure. But partially it might have been set up, and partially they will depend on the public cloud. So getting into the boundaries of both public cloud and the private cloud, okay, public cloud deployment and the private cloud deployment, it is going to be termed as an hybrid cloud. You're getting it? So public cloud, private cloud, hybrid cloud are all three different variants of deployment structures of the cloud infrastructure. So that's how we differentiate between the public, private and hybrid. But actually here, if you can see that this term can be changed. This need to be treated as a public cloud, okay? Because the public, the term is not changed here, okay? This says it's private, but actually it is a public cloud. The private cloud setup is already there in the on-premise. Hybrid cloud is this, but there is something called hybrid environment of cloud. Hybrid environment of cloud states that you need not have the AWS outpost to be deployed on your data center. You're getting it? But you will communicate with the on-premise, okay? From the on-premise, you will have the communication with the private cloud. Some of the services will be privately accessible without the deployment of AWS outpost, without the deployment of Anthos, without the deployment of Azure stack. You will have a dedicated privatized environment of communication with the public cloud, and such setup is called as an hybrid environment. You will have certain features in your on-premise and you will have certain features on your public cloud, but the dedicated setup of privatization cloud is not deployed. You will never see AWS outpost, you will never see Azure stack, or you will never see Anthos. Without that, if you still have the communication between the public and the private cloud, then that is called as a hybrid environment, but that is not an hybrid cloud. Hybrid cloud meaning is your AWS outpost have to be deployed partially, at least on the on-premise. Plus their communication will happen on the public cloud in turn as well. Okay, so that's what we call it as the hybrid environment, but this is all about hybrid cloud. The next final type of cloud that we have is multi-cloud. If you look at the multi-cloud, okay, in the multi-cloud what happens is, we as in a customer, so let's say a BMW, I'm taking an instance of a BMW. Now it's like a private cloud implementations, but what technically happens here is these the enterprise like BMW will communicate with three different cloud environments. So BMW is not associated only with AWS. BMW might be associated with the Google Cloud Platform. They will be BMW might be associated with Azure as well. So what technically happens is they will provision their services, they will provision their applications into their respective cloud platform, and the single organization is going to be connected to all three clouds. So what happens here is they might have an X application, and that application will be splitted into three different cloud environments, so that if one cloud environment is having some challenges, they will have the high availability via the other cloud platform. This comes into a picture when you are depending on a enterprise graded application deployment, and moreover the organization should be a bigger organization. Okay, economically they should be big, right? So then they will have this kind of a setup for higher availability. This setup is called as multi-cloud. Multi-cloud is like one organization connecting up with multiple cloud vendors and launching their applications into their connected cloud vendors. So this is what is all about the multi-cloud environment. And technically to say, these are like heterogeneous architecture. Multi-cloud is the use of multiple cloud computing and the storage services in a single heterogeneous environment. So how they will be connected is they might have a generic interface in order to communicate with Google Cloud Platform and as well as AWS. But that's not advisable to have a third-party interface in order to communicate commonly with AWS and Google Cloud. It's better to use AWS features separately and Google Cloud features separately, but they will be interconnected internally. So it is an heterogeneous environment. Before, the diagram what I was showing was the organization was connected to a single cloud vendor, and that's a homogeneous. But here, if you look at it, it's a heterogeneous architecture of deployment happens when they are entering into the world of multi-cloud. So these are the differences. Now, if you have any questions on this, please let me know. So this is something fundamental that we have to look at. So I guess you would have got an understanding from these diagrammatic flow that how public cloud, private cloud, hybrid cloud, and the multi-cloud is getting differentiated. So if you have any questions, please let me know. Hybrid cloud and multi-cloud seems to be similar. No, not exactly. Please mute yourself because it's getting recorded. Ensure that you are on the mute. The thing is, it's not similar. It's not similar because if you look at the hybrid cloud, okay. So what happens in the hybrid cloud is you have the dedicated environment, right? If you look at the BMW is connected only with the Google Cloud, and Audi is connected with Azure, right? And Ford is connected with AWS. But now this multi-cloud, what it simulates is it is connected, single organization connected with multiple cloud vendors. So there you can see the exact difference between the hybrid cloud and the multi-cloud. Yeah, I guess you might have got the difference. Yes. Is the private cloud is like a private server? No, it's not a private server actually. It's the whole AWS private setup is done. Okay. If you look at this, what happens here is AWS is coming to your premise and giving the complete AWS infrastructure setup into your organization. So your organization is having your own cloud space. It's obviously we will use data centers, right? Data centers carry service. So it's your own organization service, but AWS services are getting utilized in your own organization by creating your own privatized cloud environment. Let's say, for example, EC2 instances, okay, network implementations, or let's say, for example, database integrations, database instances, okay, VPC setup, virtual private cloud setup. Okay, so all these are the services which you can inherit from AWS and keep it within your data centers of your organization, and that becomes more privatized. Do we need to keep tabs on AWS competitors as well? See, not necessarily, because it depends on you might be more expertise in AWS, that's sufficient. But if you are interested to work on Google Cloud as well, okay, to get a better monetizations, okay, so you can go ahead and get skilled up on Google Cloud Platform as well. Okay, nothing harm in it, because once you learn one cloud platform, it's easier for us to apply the same skills in other cloud vendors. Probably a small learning curve is required there as well. Apart from that, it's all going to be the same fashion. Okay, whether it's going to be on Google Cloud or it's going to be on Azure or whatever it might be, doesn't matter. But what I say right now is, it's good that first let's get expertise into one AWS cloud, or let's say GCP cloud or Azure cloud, and then we think of going on to the other cloud platform. Competitors will be there and more competitors will be upcoming. Okay, but these three vendors are the major players, and number one in that in the player segment is AWS. Simple. Okay, we are entering into the AWS infrastructure. Okay, we are getting into the AWS infrastructure right now. The question that comes into our mind is, how do we choose a region? In the last class, we discussed about that region availability zone. I took you through a portal of AWS infrastructure, right? Infrastructure.aws. So there we experienced a region is there. You have an availability zone in each and every region, and you'll be having a point of presence POP. But the first question that comes into our mind is, how do we choose a region? These are architectural questions. Okay, since we are focusing on architect-based exams, we have to answer for all these questions more intrinsically. So if you look at these diagrams, so I have come up with 4 pillars of points which actually gives the answer for this question. The first answer is, we have to look at the data sovereignty. Okay, data sovereignty or compliance. This says that when you're choosing a region, you have to choose your region based on the law of the land. Law of the land. So land, what I mean is the country. In the country, let's say India might have a different data management policies, right? So when I'm trying to select a region, India, okay, and in India we have the region called Mumbai. Okay, Mumbai is a region to be technically called as. So Mumbai region, if we pick up, we need to look at the perspective of the data sovereignty and compliance. That's number 1. So if you are okay with that, your customers are okay with that data sovereignty rules and the compliance, because you cannot just like that migrate your data from the Mumbai region to some other region by having a different policy norms. You have to adhere to the land policy. That's what we call it as the law of land. Okay, so data sovereignty and compliance is something very important here. Number 2 is proximity. Okay, so my customers are located in let's say United States, and I'm placing my instances on Mumbai region. Okay, then obviously the proximity, the distance, okay, the distance between the user and the data is something bigger proximity level. So when the proximity level is increased, then obviously you will end up with a latency problem. Okay, there might be a slight latency, not that you might have some 10 minutes of latency or 20 minutes of latencies. It will be a fraction of second of latency. Even that fraction of seconds of latency might impact the customer's business. So if you are in United States, you choose the region within that particular country, okay, so that it's more feasible. Or you might have some other reasons so that you push your EC2 instance, for example, to Mumbai. Okay, for example, data sovereignty. In Mumbai, data sovereignty rules are pretty simple. So I'm going for Mumbai, but I don't mind about the latency issue. Even my customers are located in United States, but still my EC2 instances, or let's say, for example, the S3 bucket is going to be pushed into that particular Mumbai region. It's fine for me. It's fine for me because I'm worried only about the data sovereignty, because data sovereignty in United States is going to be more critical when compared to the data sovereignty and the compliance in Mumbai. Okay, so proximity means the distance between the user and the data that you are provisioning. It's data means it includes everything, your services of instances, compute instances, okay, like EC2, or it could be a database instance, anything for that matter. Then the third, what you have here is your services and features. So when you look at the services and features, what type of a services is offered by that region? That's something very important. Okay, and what are the features in it? So some services might not be available in that region. Maximum AWS is figuring out in providing all services in all regions, but that 100% availability is still not there from the AWS perspective, but their goal is that. So X service might not be there in the specific region, so you cannot choose that region. Your customer requirement or your application requirement is only dependent on that particular service, but so and so region doesn't support that particular services, then obviously you cannot choose a region. So that's number 3. Number 4 is another important point. That's all about your cost effectiveness. If you look at the cost effectiveness, some regions might have a different cost. So you are more focused towards, your organization might be more focused towards the cost effectiveness. So in that case, you need to choose a region based on the lower cost. Okay. So some smaller organization might look from that perspective. Bigger organization might look at the reliability, might look at the latency, might look at the standard compliance and sovereignty, right? So now looking at this cost effectiveness, might be some smaller organizations might have a thought of cost as well. So if you look at these terms, all the 4 have to be technically included from the architectural perspective, because the questions will be towards this. You're getting it? So the first one is law of land. You can see that there is a statement defined there called law of land, which is the data sovereignty. Law of physics is your proximity, and law of economics is your cost effectiveness. We don't have any specific law statements for services and features, because that doesn't comes under that boundary of law. So these are the 3 major law which we need to follow, along with the services and features. Based on that, we will go and choose the region. Now, so this is something from the architectural perspective. So when you are given a chance that you are supposed to go for a cloud deployment, so what are the things that you should keep in mind while you're choosing the region is the first question that will be raised. In that situation, keep thinking about these points. Okay, the compliance, the law of the compliance, and the proximity, and the cost effectiveness, that is law of economics, and the services and features. So if you have any questions on this particular slide, please let me know. So I'm taking you through these slides is because these are something that I have prepared personally in order to make you people to understand. Okay, I'm not this gives me a win-win situation, because I'm also learning the concepts parallelly. So I'm working hard in order to come up with these kind of dynamic delivery of informations. So if you have any questions on this particular slide, please. So any questions? Hope this is clear. So when you're going to choose a region, please keep all these things in mind. Okay, fine. So the next is all about AWS infrastructure. This will be quite interesting. So in AWS infrastructure, what happens? What is the complete AWS infrastructure? Now we got to know how to choose a region, but let's understand the complete flow of AWS infrastructure. Now if you look at this, the first diagrammatic flow says there is an AWS cloud. It's a global space. Okay, I'm talking about from the global perspective, the entire AWS infrastructure. Right now you're on the entire AWS infrastructure boundary, right? Now internally to it, I'm launching a region. AWS is launching one region, and that region is named as Mumbai, technically as Asia Pacific Mumbai, which is AP. AP means Asia Pacific South 1. Okay, in AP South there is one region, right? In that one region you will have multiple availability zones. We'll come to that later. So right now you imagine AWS have come forward to launch one region in Mumbai, and they have named that region as AP South 1. Similarly, there might be n number of regions that AWS might be deploying. Region is nothing but the country. Region you can think of in terms of a country where the specific location is chosen and they are deploying the region setup. Region will have the availability zones. Regions are grouped with availability zones. Okay, group of availability zones is what we are going to call it as region. So there might be multiple regions, and in each region you'll be having availability zones. So minimum of 2 availability zones should be there in one region as per the norms of the cloud cloud vendor, right? They should have minimum of 2 availability zones in the specific region, because you need to have a AZ resilient, availability zones resilient. Okay, so for that you need to have minimum 2. Why? Because I might launch an instance in AZ1, but if AZ1 is down, okay, because of different reason, then I need to have a high availability via another availability zone at least in the same region. In the specific region, I need to have an alternate availability zone. What happens here is, in Mumbai, there are 3 availability zones are there. Where these AZs are located, we don't know. In Mumbai, where these availability zones are located, we don't know. That's completely hidden. But there are 3 availability zones. We'll get to know the number of zones that are available in Mumbai. So AP South 1A is the name of the availability zone. Next zone name is AP South 1B and AP South 1C. These are the names of the availability zones. Okay. Now the same way, in the other region also you will have availability zone, keeping in mind that minimum 2 availability zones should be available in a specific region. So what AWS Cloud Global consists of is multiple regions, and each regions consist of multiple availability zones, and each availability zone will have their technical name. Now each availability zones will come up with multiple data centers in it. You can see all data centers are provisioned here, right? So all these are the data centers which are launched in the specific availability zones. That can be any number of data centers, 1 data centers or 2 data centers, that we are not sure about it. But for high availability, they will have the best of the environment from the data center perspective. So data centers will be there available in each and every availability zones. So now the next understanding here is, these availability zones are having a rule of proximity. Rule of proximity. What the rule of proximity says is, each and every availability zone in a specific region should be within the limit of 100 kilometers. That's approximately 60 miles. Okay. So AP South 1A and AP South 1B proximity, or the distance, if you see, they both will not be beyond 100 kilometers. They will be located somewhere within the 100 kilometers. You're getting it? So as per the norms of the availability zones proximity, they should have a distance maintaining within this 100 kilometers. Okay. AZs should be within 100 kilometers, that is 60 miles. Might be lesser than also. Okay. Approximately it should range within 100 kilometers. So AP South 1C and 1A should have a distance between 100 kilometers. Why that 100 kilometers of distance? Because of that natural disasters which might occur, which will not impact the other availability zone and the data centers. You're getting it? So that's how today the AWS is functioning. Because of this COVID-19, different states are coming up with different rules. Lockdown, 100% lockdown or 80% lockdown. So it will vary in the specific location. So in that case, multiple availability zones can help. This is very important number to be noted. AZs are within 100 kilometers, that is 60 miles between each and every availability zones. The next important thing in the infrastructure of the AWS is local zones. They also have a local zone. So in India, we have 3 availability zones in a specific region called Mumbai. Along with that, in Mumbai, they also have a local zone deployment. What is this local zone deployment will do is, it will have the connectivity of the region, okay, and it will be located completely closer to the customer accessibility. So this is also going to carry a data center. This local zone might also carry a data center, probably a single data center in it. But this local zone might cater the customer, the more number of customers who are located for AWS. For that customer to give a better bandwidth accessibility, they have created one local zone. The local zone is nothing but the extension of your region. You can see the diagram here. Okay. It is an extension of the region, but not inside that specific set of availability zones. Okay. It might be next to the Mumbai. Okay. Next to the border of the Mumbai. Next to the border of the Mumbai. But they are still interconnected with the region. They are still interconnected with the region. So it's an extension of the region, but giving a term called local zone, and they might have a single data center in it. So this is called as your local zone. And if you look at the definition for it, a local zone is an extension of an AWS region in geographic proximity to your users. You're getting it? So geographic proximity. Proximity is the one thing that we have to look at, right? When it comes to the region choice. So this also caters, but this will have a data center in it and has all the AWS infrastructure set up in it. The next final thing that we have to look at here is the point of presence, POP. If you look at the POP, what this POP is POP a kind of availability zone? No, not exactly. POPs are not availability zones and they will not carry any data centers in it. But they might have a servers, but not necessary that it should carry a data center. So where are the locations where we have POP in India? We have it in Chennai, Bangalore, Delhi, and also we have it in Hyderabad, but I was unable to plot them in this particular slide. Okay. So in these regions, we have the point of presence. What this point of presence does is, let's say for example, Netflix have to cater their customers by providing a 4K resolution of video content to be streamed into their customers' devices. You're getting it? So they are playing a so-and-so a movie, and the movie content is going to be cached in the POP, point of presence, which is nothing but a content delivery network. This is called as a CDN. Okay, content delivery network. POPs are nothing but the content delivery network server. It is actually called as a CloudFront. Okay, in the CloudFront, the concept is called as a CloudFront, but technically we call it as a point of presence. And here we are going to actually have the content delivery network setup. So the POP, the point of presence, are used for both AWS CloudFront to deliver content to end user at high speed. So when it is cached, when the 4K content is cached in the POP, then the users in Chennai can stream the movie without any hassles. You're getting it? So it will be of high bandwidth, high speed, the content will be delivered. So AWS is also catering such kind of a business requirement by deploying a POP, but keep in mind that POPs are not availability zones. They are only considered to be a caching component where based on the business need. Could be an example of Netflix, okay, or why not AWS own Prime Video, okay. So these can be considered for the examples of POP. So this is what is the whole infrastructure is all about, right? Your region, your availability zone, your local zone, and POP. Now the confusion is, what is the difference between local zone and POP? POP does not have the data center and the complete AWS infrastructure. But if you look at the local zone will have the AWS infrastructure in a specific data center setup. So this is the difference. If you have any questions on this slide, please let me know. So these are not just a namesake. I have given the names. These are the technical names. AP South 1A, AP South 1B and 1C are the dedicated name for the availability zones in Mumbai. And the Mumbai region name is AP South 1. Okay. Is the local zone necessary across region? No. No, local zone is an alternate option that AWS is coming forward to cater their customer. So we cannot say whether it is necessary, but it's AWS is giving you a higher availability, right? Latency problems can be resolved. High availability will be there, okay? And catering their local customers who are in that specific region. They have more customers in that specific region, in that specific location. They are extending the local zone for that purpose, okay? But whether you want to use the local zone or not, that's up to you. You're getting it? That have to be in a different approach of request that we have to go in order to deploy a local zone setup. But as a client or a customer, you can choose whether you want to go ahead with just an availability zone, or based on the requirement, you can choose the local zone as well. But that provision is also there from AWS perspective. So these are some of the differences that you might see between the vendors like Google Cloud Platform or Azure. We might have the differences in these architecture. Okay. Yeah, minimum data center in no, minimum data centers, that we are not having a number. Okay, how many data centers will be there in availability zone is not the minimum, because it might vary. It can have one data center also they can cater. That number is not there, but how minimum availability zone is 2 in one region. In one region, you need to have minimum availability as 2 availability zones minimum. Data centers are just a rack of servers, right? Rack of servers. So we cannot conclude that how many data centers will be there. Okay, this is just an example that I have given on the slide. So that numbers we might not have in the public library. You might not get the number of data centers in each and every availability zones, because it keeps varying. Obviously, you need to have minimum 1 if we consider. Okay, minimum 1 should be there in order to call them as an availability zone, because it carries it should carry a data center. So, and beyond that, it doesn't carry any specific number for it. Okay, so I guess here things are clear. There's another question. Does CloudFront away from Chennai any trying Netflix movie with a normal internet? Does content changes or data carrier? See, point of presence, it's all in the bandwidth. See, point of presence is nothing but a CDN, a content delivery network, right? So what we do is we only cache the content. So let's say, for example, you cache the content in your browser, right? While you're streaming a video on the YouTube, what the YouTube does is it keeps loading the content and caches it into your local machine, right? And from there, it keeps streaming on your YouTube player, and we are accessing it at a much faster rate. The same way here, the CDN does the same process. The point of presence is so let's say, for example, Chennai. So if it is Chennai, they can cater the entire TN region through this POP. Could be an example that we can consider. But how far the data carrier charge, that's all the dependent on the amount of data that you're going to stream. Okay, but they have chosen Chennai, Bangalore, Delhi, and Hyderabad. You're getting it. So in South, we have many point of presence in order to cater more customers. So it is in the hands of AWS to choose and deploy a POP. So we cannot go and ask for you come up with one POP on so and so region. That we cannot do. Okay, so we'll see one last thing, and after that we'll come back to the slide again after getting some demonstration on the AWS environment. Now here what you're seeing here is it's all about high availability. Okay, how do we understand the high availability? When you look at the high availability, the diagram seems to be more similar of what we have seen in the previous slide. Okay, you have the same global AWS infrastructure with Mumbai setup and 3 availability zones. Now all the 3 zones are interconnected. Please be noted, all the 3 zones are interconnected, and when we are provisioning the instances, let's say an EC2 instance or a DB instance that I'm provisioning on AP South 1C, parallelly what I will do is, as an architecture, architecture design pattern, okay, I will choose minimum of 2 availability zones in order to launch and provision my computing environment. So it could be an instance of EC2 or DB instance, doesn't matter. I'm provisioning in both the availability zones. Now what happens in this scenario is, when the customer, okay, of my customer who is going to access the services that's been offered from this availability zone, will utilize the features as long as the availability zone is up and running. As long as the availability zone is up and running, or the instance is up and running, or the DB instance is up and running, my user request can be catered. But unfortunately, if there is a disaster that occurs, okay, could be an earthquake or something in that specific location, then the availability zone goes down. When the availability zone goes down, there is the need for another availability zone which will pitch in. This can be automated with a load balancer. Now, if you look at it, the access to this particular availability zone is completely stopped. The user can't give any request to that particular availability zone. It's completely restricted. Obviously, there is no active state of that availability zone could be experienced, and so the user is facing a challenge. But you cannot give this challenge for a maximum period, right? You should have some minimum the period in which you have to give the response. So if you provision another EC2 instance or a DB instance, another availability zone, now what happens is the request will be catered by another availability zone. Once it is catered by another availability zone, this will be decided by the load balancer. We need to apply the load balancer. Load balancer will keep hitting the request to the 1C. If the 1C is not pinging back, if it's not pinging back with the response due to some reason for few fraction of seconds, immediately the load balancer will pick another availability zone. That's how the configurations have to be done in the setup, and they are available by providing the response to their user. So this concept is what we call it as high availability. You're getting it? So when one availability zone goes down, still another availability zone is there in order to cater. So while we are designing the AWS cloud infrastructure setup as a customer for the AWS, I should decide on the architectural pattern that my instances should be provisioned with minimum of 2 availability zones, but always not required, because AWS go for 11 nines principle. Okay, 99.99999% of reliability is there in AWS. 11 nines after the decimal point. Okay, 99.999, so on. So high availability, you can see always high availability is there from the AWS perspective. Okay, so I will stop here. The next concept is all about VPC and subnets, but let's go and quickly see some demo and then we'll come back to that slide. If you have any questions on this, please let me know. I guess there was a question. Then the speed is less for the middle part of the India without POP. No, it is not about the speed. Okay, see, Netflix, I'm just giving an example of Netflix, but AWS is not thinking from that Netflix point of view. Okay, AWS will not think just exactly with the Netflix point of view. They might have a different reasons to come up with the POP in specific location so that it can cater the area of geographical location to cache the content. Okay, based on their number of customers availability. Okay, based on their presence to be available on a high mode, so they come up with the POP. So if the POP is not there in the middle part of an India, will there be a latency in the content to be cached? No, obviously not. Okay, these POPs are required, for example, if you go for IoT environment, okay, Internet of Things, right, where you have to stream enormous amount of data in a fraction of latencies, then you can think of having this POP. Okay, so that's how we have to think, but we need not just think from the perspective of Netflix. Netflix is an example that I'm saying. Okay, in order to understand the POP, because it's a content delivery network where the contents are getting cached in the server to cater the specific geographical location in order to stream the content. It's not necessary that it should be video. It can be anything. It can be any data. It can be a data set, huge data set for your machine learning environment or data science environment. You might be streaming the data sets as well. Okay, any other question? Does POP and availability zones were connected, or is there connectivity anywhere else? No, they are connected. See, POPs are connected to the AZs. Okay, in the regions, they are connected to the availability zone because your actual source of data is there in the specific availability zone. Let's say, for example, Netflix is launching their content in Sydney. In the Sydney availability zone, it's there, but the point of presence is there in Chennai. Now the source is there in the Sydney. Okay, now this POP is connected. They are all interconnected, and they carry the content and then place it in the POP because this particular movie is watched frequently. Let's say, for example. Okay, so Game of Thrones is an example I can say. Game of Thrones is going to be watched by millions of people frequently. Then that particular content is going to be cached in that specific POP. But the source is coming from the availability zone. So they are still connected. So do anyone have any other question? Okay, so I guess I'm done with explaining of the concepts at my best of what is possible. Now let's get into some demonstration. Not a too complicated demonstration. It's just an heads up in order to understand some basics. So I've already created another account exclusively for our discussion. So I already own another account. So I totally have 3 to 4 accounts right now. So in this, I'm just launching into the new account. I'm logging in as a root user and MFA multi-factor authentication. I hope you all would have activated this as well, multi-factor authentication, and you would have installed the Authenticator app in your mobile. And here it's all about root account. So I need to offer 163. Hope this works. Great. So I have successfully logged in. So you can see that multiple levels of security is there. They are strengthening their security pattern. So it's good to see that. Now, so what we are going to see here is I'm going to use EC2. Okay. Elastic Cloud Compute instance. Elastic Cloud Compute instance. Elastic. Why they give a term called elastic? People who are very new to this. Elastic means it's scalable. Okay, it's scalable, so it can grow whenever needed, or it can degrow whenever not required. Okay, so it's like a band, elastic band, where it can grow and degrow. So meaning is wherever you see the term called elastic, it's more of a scalable. Okay. So this is an EC2 compute. It's a virtual machine. What we are going to create here is a virtual machine. The virtual machines are launched on top of the specific hypervisor. Okay. So it is called as a Nitro system. AWS is following their own custom hypervisor, and that is called as a Nitro system. Okay. Now EC2 instance. EC2 instance is a virtual computer, virtual machine. So how do I get into the EC2? You go to the AWS management console. This is your UI, user interface console. Once you get into the management console, you can just go and click on this EC2. Okay. Now you can see the list of services are listed out here. You can see it is find services. Other than that, you also have a recently visited services. So these are the services which I have recently visited, which is also listed out here for frequent access, for easier access. Other than that, you can also search out for the specific services that you want, because the AWS is offering hundreds of services in there. Okay, hundreds of services are there. So it's quite difficult for us to remember all the services. You're getting it? So it's good if you list out the all services. You can see here. See how many number of services that AWS carries in it. Okay, so in this specific list of services, remembering all the services is not possible. So with the keyword, you can just go and say, let's say I want to look out for S3 bucket. This is which we are going to discuss in the next week's session. I'm coming up with the preparation for that as well. So S3 bucket we'll be discussing. So that service is there, and it's all about the EC2. You can just go and access. See that it is a virtual servers in the cloud. Okay, virtual servers in the cloud. In the cloud means it's a dedicated data center that's been utilized in AWS. The one more thing is, where am I going to launch this EC2 instance? Where am I going to launch this EC2 instance? The specific region. These are region specific. EC2 instances are region specific. So you can see Mumbai is there. Okay. Mumbai, what is the name? It's AP South 1. If you want to launch in North Virginia, you just go ahead and launch it. No problem. Okay. We are on the free tier, so we have the option to launch it, but 750 hours of usage is what we need to look forward for. Okay. So once you choose your location, why I'm choosing Mumbai? Because it's nearer to my accessibility, right? So it's good to choose the nearer region. Or I might be launching an EC2. Sabari is launching an EC2 sitting from India, working for X company, so that he is launching one EC2 in sitting from India. But the customer base is there in Sydney. Okay, the customer base is there in Sydney. So where will I launch this EC2? Will I launch the EC2 in Mumbai or will it be in Sydney? Obviously, I have to launch it in Sydney. So let me go and choose Sydney. Because the functionality of this EC2 instance is going to be accessed by the customer of my organization who is located only in Sydney. Base customers are there in Sydney, right? So in that case, I need to launch my EC2 on that particular region. So it is region specific instances. Region specific instances. In the region, you can launch the EC2 into multiple availability zones as well. Okay. So if you launch one EC2 in one, now you got the idea of what availability zones are. If you look at the diagram which I've shown on the slide, you should, that's why I created that slide, because you can remember things for a longer run. How availability zone would look like. You got an idea. So now I'm going to provision this EC2 in the specific availability zone. Okay. So let me come back to Mumbai, as we are very closer to the proximity of my location. So let's go back, and we are on the EC2 dashboard. Okay. This is your dashboard. You can see it's EC2 dashboard. And in this dashboard, you can see how many number of EC2 instances are running. It says 0. Okay. And volumes is 0. That volumes is what we are going to use as the storage of our EC2 instance. Okay. Like how you have a root volume in your Linux environments, C drive in Windows environment, that is reflecting to the storage. The same way here, the volumes are storage. It is called as EBS. Okay. Elastic block storage. Elastic block storage will be predominantly used in major EC2 instances. So we need to pay for EBS also. In the free tier, it's fine. It's for 750 hours. It's okay. But in the cost perspective, we are going to pay for EBS even if you are not using the EC2 instance. If your EC2 instance is switched off, meaning is the shutdown, you have shut down the EC2 virtual machine, but still your hard disk is consumed. That is, your volumes are consumed. EBS, elastic block storage, is consumed. So we might pay for that as well. The cost will all vary. We have a separate portal where you can just go and explore about the cost involvement there. Okay. So now there is something called key pair. I will discuss about the key pair shortly. So here we can launch the instance. So if I go and click on the instances, on the left hand side, you can see a list of menu items. In the menu items, we have a number of menus being listed. So let's go to the instances, and in the instances, you can just click on launch instance. Okay. Once you click on launch instance, it will take you to a next screen where you will have the choice to choose the mission that you wanted to launch in your specific region. And it is all launched on top of Amazon mission image. So from Amazon mission image, it's an image. From the image, we are going to create one instance. And from the created instance, we can also convert to a custom image. So AMI is very important. We'll be frequently getting some questions relevant to AMI as well. So what I mean to say here is, from AMI, Amazon mission image, we are going to create one EC2 instance. From the created EC2 instance, we can in turn create another image. Why? Because I might have installed all the softwares in that particular EC2 instance. Okay. Now I want to replicate that into another region. What should I do? Will I go to the another region and then think of having a new AMI, create a new EC2 instance and start installing the softwares? Not required. From your created EC2 instance in the Mumbai region, you have loaded all the softwares to be installed in the machines. You convert them into another image and carry that image into another region and create as another EC2 instance over there. So you are not required to install the softwares from the scratch, or the configurations of that instance need not be done from the scratch. So that's what this Amazon mission image means. So we will discuss more probably once we get the chance to move on to the advanced sessions. Right now we are on the launch of the EC2 instance space. But what I wanted to explain is, I just wanted to go back to my dashboard of the EC2. Here you can see there is a key pair. This key pair is something very important. People who are already worked on it might new. I'm just reiterating the concept for the people who are pretty new to this environment. So key pair are very important. It carries a public key and a private key. Okay, the key pair will carry a public and private key. Public key, okay, so the public key is something which the key is going to be known. Okay, private key is something which is not known. So the unknown key, the private key, have to be matched with the public key. The unknown private key element should be matched with the public key. That's what we say it as a key pair. Now when you access your EC2 instance, you have to provide the key pair. Okay, only then you will be having the access for that specific EC2 instance. So let me go ahead and create one key pair. Here you can see there is an option to create a key pair. Let me click on that, and you provide a name for it. So let's say, for example, Sabari, okay, key pair 1. And there are two options. One is PEM format of key pair, another one is PPK. Okay, I don't have an SSH access in my mission currently, so I'll be unable to use the PEM format of key pair. Instead, I will go for PPK, which is used via the third-party tool called PuTTY. Okay, probably most of you would have accessed that PuTTY in order to access the remote missions, Linux missions, Linux missions to access. You'll use the PuTTY. Similarly here, I'm going to use the PuTTY to connect to my mission. So I need a PPK format of key pair, and let's go ahead and create a key pair. That's all we have to do. Just provide a name. The key pair is created. You're getting it? So this is just a key pair that we have. And in this specific key pair, based on this created key pair, you'll be having the public key and private key generations that we will see at the time of launching the instance. So right now I have just created a single key pair and kept it safe in my account. Okay, in my AWS account, I have created one key pair. You can create as many number of key pairs you want it. Okay, so now once I go back to the EC2 instances and let me click on the launch, you can see there are n number of AMIs are available. Amazon mission images are available. Okay, n number of AMIs where it talks about Amazon Linux, Ubuntu. Okay, you have deep learning related software set up in the operating system already predefined. Okay, there are a lot of things, and even Windows servers are there. Windows Server 2012 R2 base and SQL Server 2019 Enterprise Edition of Windows Server operating system. These are operating systems. Whatever I'm listing right now here is all operating systems. You have to choose the operating system. But there are operating systems which are free. If you click on this free tier only, it will list only the free tier operating systems. Okay, you can see only the list of free tier operating systems. And these free tier operating systems is what you are going to use in order to launch it as an EC2 instance. Okay, so if I remove this free tier checkbox, then you can see that there are paid versions of instances are also available. These are paid versions. Wherever you see the tag of free tier eligible, those are the only instance you are supposed to use. I'm not going to launch a Windows server because the memory is going to be 1 GB. I cannot launch the Windows server with 1 GB instantly. So it will take some time to load it. So that I cannot use it. If I want to use it with more memory, then it's a cost incurring. So I cannot go with that as a demonstration. So what I do is right now I'm going to use this first. Okay, let me go for the second option. This is also a free tier. But what you can see is it is inbuilt with Java, Python. Everything is pre-built, pre-installed. If you are working on containerizations like Docker, okay, all these are pre-installed in this particular AMI image. you can create an instance from this image. So I'm going to select this. Now you can see a list of tiers of instances are available. In this, you are going to use T2 micro free tier eligible, T2 micro free tier. Please be noted, you are supposed to choose only the free tier. By default, the Amazon Web Service is helping you to choose only the free tier. If you want something else, then you have to look at the cost. So I need a 8 GB of RAM. If you need 8 GB of RAM, then you go for T2 large. If you want 16 GB of RAM, you go for T2X large. These T2, the M5, all these are different processing powers of images, okay, which will vary in its price as well. So let's go ahead and choose this free tier instance right now, where the network performance will be low to moderate. Sometimes it will be low. The network bandwidth will be low because it's free tier anyways, and we are offered only with 1 GB of RAM. 1 GB of RAM, and the storage is EBS. So what EBS means, as I said, elastic block storage, right? Is the instance storage component. Now once you have chosen this, you can hit next, configure the instance details. If you look at here, how many number of instance you wanted. Anyways, I'm going to launch one instance. If you want multiple instance, then auto scaling is as an option you can choose. So what happens in the auto scaling is it keeps growing its number of instances as well. Once you set up a load balancer, since you have two instances, all instance will not be running. One instance will be running, the other instance will be backup. So load balancer will decide based on the request that's coming in. That's all a different story which we have to learn it as we go along in the long run. But right now you can choose as one instance, and then you can look at the network options here. This network option is the place where we talk about the virtual private cloud, VPC. Okay, if wanted, you can create a new VPC. VPC means it's a private network that we create. Okay, a virtual network. VPC is nothing but virtual network. Let's take an example. In your organization, you might be having a network setup, right? And your organization machines can be connected within the specific private network of your organization setup, right? That is physical setup what you're seeing. But on the cloud, we can create a complete network setup, and that's called as a virtual network. By default, when an account is created, AWS account is created, one default VPC is created. So what is that VPC? I'll explain you in the slide. So right now you understand that VPCs are virtual private cloud. In the virtual private cloud, you will have subnet. Subnet means subnetworks. Okay. So one VPC might have an option to deploy, let's say 100 IPs. Okay. 100 IPs, and in the 100 IPs can be divided into 25, 25, 25, 25. For example, I'm saying. So 25 IPs can be divided. So we are getting 4 different group of IPs. Okay, IP addresses, and that is going to be set in a subnet. So there is a default subnet is offered again. So you can go ahead and choose your specific subnet if needed. But you can leave it to the default, so it will choose anyone. Why only 3 subnets are there? Because we have 3 regions in Mumbai. You're getting it? So in each 3 availability zones in Mumbai region. 3 availability zones in Mumbai region. So in each availability zone, 1 subnet is provisioned, and you can choose your specific availability zone subnet. Or you can leave it to the AWS EC2 instance automation tool, which would automatically pick 1 availability zone as well. These are the things which we will be accessing it when it comes to the VPC setup. Right now, leave it to the default. So why I'm talking about these 2 things is very, very important. More number of questions will be asked from VPC. You need a networking skill as well, a bit of networking skill. So please do get some skills on networking as well. Lot of questions on architectural perspective from the network and subnet will be there. So once we have left it to the default choices, you can just go straight into it and click add storage. I guess I've given the rest of the informations. You can click add storage. In the add storage, 8 GB of capacity of volume that I'm creating. Okay, 8 GB of capacity of volume, but you can maximum grow to 30 GB. You can see here free tier eligible customers can get up to 30 GB of volume. This is a root volume. You can add a new volume. Okay, like for example the D drive, E drive, F drive. Okay, so for root I'm dedicating it to 8 GB, and in my D drive I'm going to dedicate it to 8 GB. So I'm consuming 16 GB, which is coming within the limit of the 30 GB memory allotment for free tier customers. So you can create your volumes as per your requirement. I'm not choosing it right now, so leaving it to the 8 GB itself because it's just a demonstration purpose. You can leave it as such and go to the next, and here tags are additional metadata that you offer to your EC2 instance so that it's easier for us to capture the EC2 status. It's not required mandatorily, but it's optional. So I'm just going to say Sabari as a key name and EC2 instance demo as a value. This is just for a metadata. Okay, it's just a metadata. Nothing too complicated. Don't confuse here. It's just a added metadata, a tag which we are adding on to top of the EC2, which can be used for later status informations gathering. So you can hit on the configure security group, and here I'm leaving it to the if you have any existing security group, you can go and use it. Otherwise, you can create a new security group. In the new security group, I'm saying it's SSH and SSH request that we are going to use in that specific EC2 instance. If you're going to use that for HTTP, you can add that rule as well. You can click on add rule and then choose HTTP. You can give a request to that mission through HTTP protocol. You're getting it? But right now I'm not going to use for HTTP. If there is any web server available, then probably you can give a HTTP request. So right now I'm going to choose SSH request, TCP protocol 22. This is a Linux mission. Right now what we are launching is a Linux mission. So it's a port of 22. If it's a Windows mission, then you will be going for RDP, remote desktop protocol, and the port number there is 3389. Yeah, 3389. But right now it's a Linux, you can leave it as such 22. But the one important thing that you have to notice here is there is a source. You can see there is a source label. There you have something called custom. Okay, I'm not going to choose custom. Instead, I'm going to say my IP. So who can connect to this EC2 is only with the IP of this, or you can have anywhere. Okay, anywhere means, see, immediately you're getting a warning. If you give it anywhere, anyone can access. It's like a public access. Okay, so I don't want to do that. So I'm just protecting it that only my IP, my mission IP, my network IP can access this EC2 instance. You're getting it? So the source information is very important. Just have a look at it because in exam there might be a question. Because I've seen some of the practice exam questions that these might be more minute informations, but still from architectural perspective the questions are there. So go and click on review and launch. That's all, review and launch. And I guess you can just go back and figure out what are all the complete information, complete configurations being done. So it's a report, it's a complete report before you launch. You can go through it. If in case you want to modify something, you can come back previous and then do some modifications. And click launch, here where the question comes. So what this dialog box is all about, or the wizard is all about, the wizard says a key pair consists of public key that AWS stores. Okay, a key pair consists of a public key that AWS stores and a private key that you will store. You means now it's Sabari who's creating an instance. So Sabari had already created a key pair, and I'm telling the AWS to use that key pair of pattern. Otherwise, you can leave it, proceed without a key pair also, but that's not highly recommendable. That's not highly recommendable. Please go ahead with the key pair. Create a new key pair if needed, you do it. But already I've created, I own a key pair. So I'm going to choose that key pair which I've already created. You remember the name that we have given there is summary-kp1. Right. So what happens here is the existing key pair is used to create a public key and a private key. Who will have the public key? AWS store will carry the public key and I will carry the private key. If I want to connect, I need to authenticate with my public key to the AWS store. AWS store will validate the public key, private key with the public key that it is owning, and then it will give the permission to access the instance. So let me say I acknowledge and then launch instance. Even if you forget to create a public, key pair, no problem. You have the choice to create a new key pair. Okay, no worries. So you can just click on launch. Okay, so here, yes, choosing the right key pair. Just go ahead. Okay, so now here the instance status is getting checked. Meanwhile, let's go to the, so you can see the instance state is saying it's running and the status check is initializing. So once that is done, we have the access to the EC2 instance. You can see the public IP that's captured. Let me explain this. You can see the running instance is 1. You can see the volume is 1. So volume is like in the EBS elastic block storage. Elastic blocks storage. You can see the volumes, and there it has created 8 GB of disk memory. Okay, so that's what you are seeing it as a 1 volume. And okay, now the status check has got completed. It's 2 of 2. So we have the private key here. I didn't see the downloaded task. So it got downloaded. The private key got downloaded since we are mapped with the existing key pair. Now what we have to do is we'll just take that key pair, the private key, and then place it in some specific location. Let's say I go ahead and drop it in one specific folder, key pair. Okay, this is my private key. Okay, I need to hold this in order to connect to this instance. So the instance is up and running. And also if you notice here in the dashboard, the key pair is 1, volume is 1, running instance is 1. The most important thing that you have to notice is they have a default security groups which is mapped. Okay, we'll discuss security groups a bit later. Now, the thing is, this particular instance got deployed on the default VPC, which I've already explained at the time of creating the EC2 instance. So let's go for PuTTY. I'm opening the PuTTY tool. And here, if you look at the instance IP is here. You can just copy the instance IP, the EC2 instance IP, and you can drop in here. Please remember that the port is 2222 and I'm hitting a SSH request. Okay, so here you have to come to this SSH and you will have the authentication. In the authentication menu, you will have the option to browse for the private key. So where the private key is, I've located in my D drive key pair directory, and there I have this private key. You need to open this. Remember that it's an extension of PPK. That's the reason I'm using PuTTY. And with this offering of the private key, you can just open it and provide the permission to access the network. It prompts for the login. EC2-user, okay, is the authentication login name. So once you have offered, no password is required because public key is verified. Your given private key is authenticated with the public key that was carried by the Amazon store. Okay. So here you can see Amazon Linux AMI. Linux AMI is what I'm using right now. So we are on top of this virtual machine, sitting on top of this virtual machine. You can just go ahead and see if Python is working, let's say. Okay. Yes, of course, Python shell is triggered, and you can check out if the shell is giving you the response. Just an example. Okay. So it works fine. So you do have Java installed in this machine, so you can check for Java version. Okay. So it says it's 1.7. So now the thing is, we are connected to the virtual machine. So it might not take more than 5 minutes. Since it's a demonstration, I've taken you with all the explanations and then we landed up here. Okay. So you are supposed to create this in just 5 minutes of time, and you're ready and up and running with your virtual machine. So for 750 hours, this machine can be running per month. Per month, you can keep running this for 750 hours. After that, it carries the charge. It incurs the charge, and you'll be charged for the number of hours or the minutes that you're going to use. Is that clear till now? If you have any questions, please let me know. I guess we are running out of time. It's already 8:30, but I'll take another 10 more minutes to understand the VPC basics. EC2-user is the default user credential. Okay, that will be the default user credential of that's the root user. That's the root user. Post which you can go ahead and create multiple users in this machine. Using the Linux command, you can start creating the users as well. Okay, but you are given the root access. Okay. Yeah. All EC2 instance will have the root user name as EC2-user only. Yeah. Any other question? Do anyone have any other question? Please let me know. So your EC2 instance is sitting on top of a particular virtual private cloud, but they have the access via the internet gateway, public internet. I will explain you shortly. I will take another 10 more minutes. Please bear with me, because we'll complete that theoretical understanding at least, and we will catch up with the demo in the next week as well. Okay, so I guess there are no questions right now. So the steps are pretty clear. You can go for your choice of your free tier instance and then launch them. The AMI's images are used to create an instance. We set the key pair and then get the private key and then validate it with the public key, and you're there to go ahead and launch the instance that you have created. Okay. So now let me move back to the slide. We'll spend a few more minutes. So here, VPC and subnets. Okay. So what is this VPC? Virtual Private Cloud, and subnets is nothing but subnetworks. Okay. Now, virtual private cloud. A virtual private cloud is a virtual network dedicated to your AWS account. Default VPC is dedicated for your AWS account. The moment we create one AWS account, we have a VPC created, a default VPC, and a default subnets are created. It is logically isolated from other virtual networks in the AWS. Logically isolated, but not physically. Each and every VPCs are physically connected, but logically it seems to be isolated, means you're secured from not accessing other VPC. Logically, you cannot access the other VPC, but physically their network connectivity will be there. But logically, you're unauthorized to access other VPC until it is getting configured. So, okay, you will not have access to the other VPCs. You can launch your AWS resources such as Amazon EC2. That's what we did right now. We created an Amazon EC2 instance, and then we provisioned into the VPC, Virtual Private Cloud. You can specify an a VPC IP address range if needed. If there is a need, you can provide it using the CIDR. Okay, classless inter-domain range of IP addresses can be used. CIDR, I guess I've already shared the CIDR website address to work out and understand the CIDR ranges. And you can add a subnet in your VPC. Okay, subnetworks. it means, and you can associate a security group to the VPC. Based on the security group, your resources will get launched into the VPC, and you can configure your route tables. Route tables will have the IP address chart, ranging chart, and the internet gateway informations. Looking at the route table only, your inbound and outbound access will be there within the VPC's subnet. So a subnet is a range of IP addresses in your VPC. Subnet is a range. You will have multiple subnets in one VPC, and those subnets will have a range of IPs which is allotted within the range of the VPC's IP addresses. So what you can do with the once the VPC creation is done, you can set the range for IP address, you can create subnets, you can create, you can associate security groups, and you can configure route tables. Fine. Now look at this diagram flow. We have a region. In the region, we have the virtual private cloud being created. In the specific region of Mumbai, for your account, you have a VPC available. And this is your default VPC. Please be noted, this is your default VPC available. By default, VPC will be there. Only with that VPC only, you can launch your instances, compute instances or DB instances. Okay. So this VPC will have a range, CIDR range. 172.31.0.0/16 is the CIDR range. Okay. Now this has expansion of availability zone. This VPC is utilized to launch 2 availability zones, or let's say in Mumbai we have 3 availability zones. All the 3 availability zones will be used with the expansion of this single VPC. Default VPCs, you have zone A and zone B, and in that availability zone, okay, of that specific VPC slab, we are launching the subnet, public subnet. It is a public subnet. We have 2 things. One is private subnet, another one is public subnet. Let's not discuss about the private right now. Let's understand a public subnet is launched. Then you have a split up now. You are seeing that the total range is 172.31.0.0/16 is what is going to be split up into multiple subnets. Okay. Right now I have 2 public subnets and the range is splitted. Okay. The higher you provide the CIDR range, the lower IPs will be created. So I'll just show you shortly with this, people who are not aware of that. You can just look at this. This is an example that we can take. 10.0.0.0/21 is the CIDR range. The range is provided, and you can see 10.0.0.1 is the starting IP to 10.0.7.254 slab of IPs are there. So the total IP that you can consume there is 2048 IP addresses are there. 2048 IP addresses are allotted in VPC. Okay, this is your VPC allotment. From the VPC, I am creating SB1, subnet 1, and then subnet 2, subnet 3, and subnet 4. Okay, in subnet 1, look at this. This is the subnet 1. In the subnet 1, the range that I am giving is 24. So 24 is higher CIDR block. Okay, higher CIDR block, so that the number of IPs will be less. But all these are higher when compared to this 21, because you need to group them within the specific number of IPs that are available. So now the range is 1 to 254. So it is coming to 255 actually. It's not 256. We include that 0 also. So it should be 255 IP addresses are allotted for the subnet 1. Next, again the range will vary. We'll start from 10.0.1.0 to 10.0.1.254 range by using the same 24 CIDR range, by giving the starting IP address as 10.0.1.0, and you have a 255 IP address, number of IPs. Then we go for 23, you get 512 IPs in the subnet 3, and again you keep changing your starting IP address, and accordingly you get the number of IPs to be dedicated for the subnet. So how these subnets are splitted? We have totally 2000. If you count this, 500, 500, 1000, 1500 IP addresses have been consumed so far from the 2048 IPs that are available. So VPC is the place where you allot the number of IPs totally to be consumed for that particular virtual private network. From that total number of IPs, you will keep dividing it into multiple segment of IPs grouping with the help of subnets. That's why it is called as a subnetwork. You can apply the policy, security policies on top of this subnet. Now, having said with this, we will have an exclusive session on CIDR later. Okay, probably I'll try to come up with some 30-40 minutes of exclusive session on CIDR, because CIDR is very important. As you go along with the AWS learning, you need to use CIDR ranges effectively in IPv4 and as well as in IPv6. So now here you have the router. Okay, the router comes in and it's been shareable across these two public subnets because they are all part of the same VPCs, and this router will route through the request within this subnet, and there will also be a gateway. Okay, internet gateway. You can see there's an internet gateway, and this internet gateway is the only chance in order to communicate with the public internet. You have a public internet, so you want to communicate with the public internet, then you need to set up the IGW, internet gateway. Okay, while you're creating a VPC, you can use internet gateway. If you don't use an internet gateway, then your VPC subnet can never communicate with the public internet. There where we set up the privatized subnets. Now it is public subnet. You can look at the name. The name of the subnet is public subnet, so that the IGW, the internet gateway, is enabled. If you don't have the internet gateway enabled, then it is going to be considered as a private subnet. You cannot communicate with the public internet. The inbound and the outbound request and response can never happen with the public internet. You will be completely isolated. You're completely isolated from the public internet access. So now I'm launching the EC2 instance in the public subnet. Default, just now we did that, right? So I'm launching the EC2 instance in the specific public subnet, and these two are going to be interconnected. How? Using the router. These are local connectivity. What you're seeing here is a local connectivity, and they can communicate to each other. If needed, the EC2 instance can go out of the public subnet and communicate with the public internet also. Let's say, for example, from the EC2 instance, let's take this example. Here, I want to download. Let's say, for example, I want to download one Tomcat server. Okay, I can download it. Why? Because this EC2 instance which we are running right now is on the public subnet, default public subnet, and the default public subnet is already enabled with the internet gateway. So I can go all the way to the public internet and download the Tomcat server. But if it were a private subnet, okay, if it's a private subnet and you don't have an IGW, the internet gateway, then sure, you cannot download Tomcat server, because the outbound and the inbound are completely restricted in terms of public connectivity to the public internet. So you cannot. From the outside world, I'm a person who's in the internet, public internet. I cannot communicate with this instance, and this instance can't communicate with me because it's completely isolated. But you can still have an outbound request. Okay, from instance you can go out, but from outside you cannot come into the instance. That is called as egress internet gateway, EIGW. We'll see those in the advanced study. EIGW is egress internet gateway. What that egress internet gateway does is, your private subnet can go out and communicate to the public internet, but the entity who's in the public internet can't go as into the subnet. Means inbound is restricted, outbound is accepted. That's what is your egress internet gateway. That will be quite interesting in the demonstration. In the hands-on, it will be quite interesting, because there where I will show you how to create a VPC, how to create a subnet, how to create a public subnet and a private subnet, how to make sure the communication happens with the internet gateway and with the egress internet gateway. All these we can see in the demonstrations of the next upcoming sessions. Okay. So if you have any questions on this of the base understanding, please let me know. So by any means, once you create an account, you will have your virtual private cloud. I can also show you in my account. So So I can just go back to the AWS management console. You can type in the VPC. Okay, click on the VPC. You can see here there is a VPC1 is available in Mumbai region. How many subnets have been created? 3 subnets. These are default subnets. Default subnets will have already associated with the internet gateway. You can see here it's already been associated in the internet gateways. Just taking some time. You will actually have the option to see the internet gateway is getting associated. See, it is attached. Attached to whom? To the default VPC. That's the reason that I said inbound and outbound to the public internet is possible. So my instance, EC2 instance, which I have provisioned, is actually provisioned on top of this VPC, and this VPC has 3 subnets. You can see 3 availability zones, and in each availability zone there is 1 subnet provisioned. I'm not sure which subnet that it has chosen, because I left it to the EC2 automation tool to go and choose for the subnet and launch the EC2 instance into it. As simple as that. So this information is sufficient just to show you that there is a default VPC is available. You can also check that. You can also check that here. Okay. You have the default VPC, yes. If it's a custom VPC, here the statement will be no. It is not a default VPC. You can remove the default VPC. If you needed, you can go ahead and delete the default VPC by using the action. You can delete the default VPC. You can also create a new default VPC if needed as well. Okay, you can once it is deleted, you will have the option to create a default VPC. Now the option is disabled because it's already there. Before, what happened was we need to raise a request to the AWS support team, and they will help us in creating a default VPC if by mistake we have deleted the default VPC. But now we can create it by ourselves. If by mistake you have deleted the default VPC also, you can go ahead and create one new default VPC as and when required. But overall, there can be only one default VPC for your account. Please hold on here. This is very important. Once you go back to your creation of EC2 instance, because this is something very important, just go to the EC2 instance, running instances from the dashboard. You can see the instance. Here the action is there. You can click on the instance state. Please stop them. Please stop them so that your 750 hours will not be consumed. Stopping is very important. So there are 3 states: running state, stopping state, and termination state. Running, stop, termination. Right now I'm stopping it. So from running you can go to stop and then go to terminate, or from running you can directly go to terminate. What happens in the terminate? I'll tell you. Only when you terminate, your EBS utilizations will not be there. Please be noted. In the dashboard, you can see everything becomes 0. Running instance is 0, but your volume is still 1. Volume is still 1, meaning is your elastic block storage is still attached with your instance. But if I go to the instance and if I terminate it, then and there you terminate it, so that you will not be worried upon. But remember, so select it, instance state. From the stop state you can go to terminate, or else you can start it again. So it's all about shutdown. Okay, reboot, shutdown, boot it, and terminate it completely. So when you terminate, EBS volume storage will be completely deleted. Yes, please proceed and then terminate it. No worries about. Please go ahead and terminate is what I'm instructing, so that it's completely terminated. Once it is terminated, this instance can't be waked up. This instance can't be used. So if you go to the dashboard, you can see your volume becomes 0. Your volume is 0. So no more usage of EBS. No cost incurring in that. So in that case, termination is very important. Once you practiced, please go ahead and terminate it. You have the actions menu tab here. Just click on the tabbed menu. You can go and choose the instance state and keep switching between the state of the instances. Termination is very important. Once terminated, you can never use this instance. If you want to use another instance, you have to go ahead and launch an instance. That's the only way. I'll stop here. We'll take more questions if there are on the group. So till then, have a great day and stay safe. We'll connect up on next week's session. Thank you all.